NASA has been doing a pretty good job in their research and development field. While a number of their theories have been proven to be not true, some of them might actually be true, and the latest insider has just revealed that something really big is going to hit us and we won't be able to cushion its impact. But what is this big thing? Why has NASA been keeping it a secret? Is it something to worry about? Continue watching the video till the end to know more. Hey everyone, and welcome back to yet another video from our channel. We hope you guys are doing extremely well. In this video, we will be talking about the latest insider from NASA regarding this NIG thing that is going to hit our planet Earth. We will be diving deep into every aspect of this news, so if you are new to this channel, then make sure to hit the subscribe button. Now, without any further ado, let's hop right into the video. Asteroid 2022 EB5 was too small to pose a hazard to Earth, but its discovery marks the fifth time that any asteroid has been observed before impacting into the atmosphere. A small asteroid hit Earth's atmosphere over the Norwegian Sea before disintegrating on March 11, 2022. But this event wasn't a complete surprise. Astronomers knew it was on a collision course, predicting exactly where and when this impact would happen. 2 hours before the asteroid made impact, K. Soneski at the Piskestado Observatory in northern Hungary first reported observations of the small object to the Minor Planet Center, the internationally recognized clearinghouse for the position measurements of small celestial bodies. The object was posted on the Minor Planet Center's Near-Earth Object Confirmation page to flag it for additional observations that would confirm it was a previously unknown asteroid. NASA's Scout Impact Hazard Assessment System then took these early measurements to calculate the trajectory of 2022 EB5. As soon as Scout determined that 2022 EB5 was going to hit Earth's atmosphere, the system alerted the Center for Near-Earth Object Studies, CNEOS, and NASA's Planetary Defense Coordination Office, and flagged the object for the Scout webpage to notify the Near-Earth Object Observing Community. Maintained by CNEOS at NASA's Jet Propulsion Laboratory in Southern California, Scout automatically searches the Minor Planet Center's database for possible new short-term impactors. CNEOS calculates every known near-Earth asteroid orbit to improve impact hazard assessments in support of the Planetary Defense Coordination Office. Scout had only 14 observations over 40 minutes from one observatory to work with when it first identified the object as an impactor. We were able to determine the possible impact locations, which initially extended from western Greenland to off the coast of Norway, said David Farnosia, a navigation engineer at JPL who developed Scout. As more observatories tracked the asteroid, our calculations of its trajectory and impact location became more precise. Scout determined that 2022 EB5 would enter the atmosphere southwest of Jan Mayen, a Norwegian island nearly 300 miles or 470 kilometers off the east coast of Greenland and northeast of Iceland. At 5:23 p.m. Eastern Standard Time, 2:23 p.m. PST, 2022 EB5 hit the atmosphere as predicted by Scout, and infrasound detectors have confirmed the impact occurred at the predicted time. From observations of the asteroid as it approached Earth and the energy measured by infrasound detectors at time of impact, 2022 EB5 is estimated to have been about 6.5 feet or 2 meters in size. Tiny asteroids of this size get bright enough to be detected only in the last few hours before their impact, or before they make a very close approach to Earth. They are much smaller than the object that the Planetary Defense Coordination Office is tasked by NASA with detecting and warning about. Tiny asteroids like 2022 EB5 are numerous, and they impact in the atmosphere quite frequently, roughly every 10 months or so, said Paul Chodas, director of the CNEOS at JPL. But very few of these asteroids have actually been detected in space and observed extensively prior to impact, basically because they are very faint until the last few hours, and a survey telescope has to observe just the right spot of the sky at the right time for one to be detected. A larger asteroid with hazardous impact potential could be discovered much farther from Earth. NASA's goal is to keep track of such asteroids and to calculate their trajectories in order to have many years' notice ahead of a potential impact should one ever be identified. But this real-world event with a very small asteroid allowed the planetary defense community to exercise capabilities and gave some confidence that the impact prediction models at CNEOS are highly capable of informing the response to the potential impact of a larger object. 2022 EB5 is only the fifth small asteroid to be detected in space before hitting Earth's atmosphere. The first asteroid to be discovered and tracked well before hitting Earth was 2008 TC3, which entered the atmosphere over Sudan and broke up in October 2008. That 13-foot wide or 4-meter wide asteroid scattered hundreds of small meteorites over the Nubian desert. As surveys become more sophisticated and sensitive, more of these harmless objects will be detected before entering the atmosphere. Analysis of data obtained over the past 2 weeks by NASA's Double Asteroid Redirection Test (DART) investigation team shows the spacecraft's kinetic impact with its target asteroid, Dimorphos, successfully altered the asteroid's orbit. This marks humanity's first time purposely changing the motion of a celestial object and the first full-scale demonstration of asteroid deflection technology. All of us have the responsibility to protect our home planet. After all, it's the only one we have, said NASA Administrator Bill Nelson. This mission shows that NASA is trying to be ready for whatever the universe throws at us. NASA has proven we are serious as a defender of the planet. This is a watershed moment for planetary defense and all of humanity. demonstrating commitment from NASA's exceptional team and partners from around the world. Prior to DART's impact, it took Dimorphos 11 hours and 55 minutes to orbit its larger parent asteroid, Didymos. Since DART's intentional collision with Dimorphos on September 26, astronomers have been using telescopes on Earth to measure how much that time has changed. Now, the investigation team has confirmed the spacecraft's impact altered Dimorphos' orbit around Didymos by 32 minutes, shortening the 11-hour and 55-minute orbit to 11 hours and 23 minutes. This measurement has a margin of uncertainty of approximately plus or minus 2 minutes. Before its encounter, NASA has defined a minimum successful orbit period change of Dimorphos as change of 73 seconds or more. This early data shows DART surpassed its minimum benchmark by more than 25 times. This result is one important step toward understanding the full effect of DART's impact with its target asteroid, said Lori Glaze, director of NASA's Planetary Research Division at NASA's headquarters in Washington. As new data come in each day, astronomers will be able to better assess whether and how a mission like DART could be used in the future to help protect Earth from a collision with an asteroid if we ever discover one headed our way. The investigation team is still acquiring data with ground-based observatories around the world, as well as with radar facilities at NASA Jet Propulsion Laboratory's Goldstone Planetary Radar in California and the National Science Foundation's Green Bank Observatory in West Virginia. They are updating the period measurement with frequent observations to improve its precision. Focus now is shifting toward the measuring the efficiency of momentum transfer of DART's roughly 14,000-mile, 22,530 km/h collision with its target. This includes further analysis of the ejecta, the many tons of asteroidal rock displaced and launched into space by the impact. The recoil from this blast of debris substantially enhanced DART's push against Dimorphos, a little like a jet of air streaming out of a balloon sends a balloon in the opposite direction. To successfully understand the effect of the recoil from the ejecta, more information on the asteroid's physical properties, such as the characteristics of its surface and how strong or weak it is needed. These issues are still being investigated. DART has given us some fascinating data about both asteroid properties and the effectiveness of a kinetic impactor as planetary defense technology, said Nancy Chabot, the DART coordinator lead from the Johns Hopkins Applied Physics Laboratory, APL, in Laurel, Maryland. The DART team is continuing to work on this rich data set to fully understand the first planetary defense test of asteroid deflection. For this analysis, astronomers will continue to study imagery of Dimorphos from DART's terminal approach and from the light Italian CubeSat for imaging of asteroids, Lycia Cube, provided by the Italian Space Agency to approximate the asteroid's mass and shape. Roughly 4 years from now, the European Space Agency's HERA project is also planned to conduct detailed surveys of both Dimorphos and Didymos, with a particular focus on the crater left by DART's collision and a precise measurement of Dimorphos' mass. Johns Hopkins APL built and operated DART spacecraft and manages the DART mission for NASA's Planetary Defense Coordination Office as a project of the agency's Planetary Missions Program Office. Telescopic facilities contributing to the observations used by DART team to determine this result include Goldstone, Green Bank Observatory, Swope Telescope at the Las Campanas Observatory in Chile, the Danish Telescope at the La Silla Observatory in Chile, and the Los Cumbres Observatory Global Telescope Network facilities in Chile and South Africa. Neither Dimorphos nor Didymos pose any hazard to Earth before or after DART's controlled collision with Dimorphos. And that's all for today. Did we miss out on anything? Do you have any other insights on this news? Did you enjoy watching the video? Let us know your thoughts in the comments section down below. Well, that brings us to the end of this video. We hope you've enjoyed watching the video. Please like the video if you have not already done so, and make sure to hit the subscribe button. Don't forget to press the bell icon to never miss another update from our channel. With that being said, let's meet in another one of these videos. Until then, see ya!